Alright, let's look at the homework 4.4, problem number 10. Alright, so here's a function, x squared plus 4x minus 21 all over x squared minus 6x plus 9. Alright, so first we want to find the domain. Alright, so first I'm going to say the note said that these rational functions are not reduced to lowest terms. Alright, so I'm going to actually factor out here. Alright, so we can factor out the numerator. That's going to be x minus 3 times quantity x plus 7. Right, now on the bottom it's actually x minus 3 squared. Right, so why not reduce to cancel out the x minus 3 and one of these. Right, so this is actually x plus 7 over x minus 3. Right, so if you want to find a domain, you can see that x equals 3 would be bad, so all real numbers except for 3. So here, check the answer. So we got that. Alright, then x-intercepts and the y-intercept. So let's find that. Alright, so in order to find the x-intercept, right, we set this guy equal to 0. Which means that the x plus 7 is equal to 0. Which means that x equals negative 7. Right? If you want the y-intercept, then you set you just put the 0 for x, which is going to be 7 over negative 3. Right? So y-intercept is negative 7/3. Right? So let's see if we can find that. So x equals negative 7 and the y equals negative 7/3. Alright, seems like this is the one we're looking at, right? So x equals negative 7 and y equals 7/3, negative 7/3. Alright, so check that. We got that. Alright, then we have we want to find the horizontal asymptotes. Alright, so let's look at that. And the vertical asymptotes. Right, we have since x equals 3 makes this equal to 0, so vertical asymptote would be x equals 3, right? And a horizontal asymptote, so you have to take the limit of x plus 7 over x minus 7 as x approaches infinity. Right? Since we learned L'Hopital's rule, so let's apply L'Hopital's rule here. Infinity, infinity over infinity. So you have a limit, x approaches infinity, and it's 1 over 1. So this is going to give you 1, which means that the horizontal asymptote is y equals 1. So x equals 3 and y equals 1. The negative 1 is going to give you the same answer anyway. So let's see, y equals 1 and x equals 3. So this is that. Alright, so check the answer. I got that. Alright, then we have to look at the first derivative. So we take the first derivative of this function because we already simplified that. So first derivative is going to be quotient rule. Square the bottom, x minus 3 squared. Take the derivative of the top, 1, times the bottom, x minus 3, minus top, x plus 7, times derivative of the bottom is 1. Alright, this simplifies to x minus x cancel out, negative 3 minus 7, so it's negative 10 over x minus 3 squared. Alright, then you can see that this is going to be always negative, which means that it's going to be always decreasing, right? So let's find that. So it's decreasing on everywhere except for 3. So this has got to be it. So yep. Alright, so local max and the local minimum, since it's always decreasing, there is no local extrema. Alright, we have that. And we have to look at the second derivative. Alright, so take another derivative. So we have f prime, double prime of x is equal to, alright, we can rewrite this guy as negative 10 times quantity x minus 3 to the negative 2 power. So the derivative would be, let's see, put negative 2 in front, so it's a 20. Then you have x minus 3, and then subtract 1 from the power, it's negative 3. Multiply by derivative of that, it's going to be that. So you have a 20 over x minus 3 cubed. Alright, then we can look at, we can do a number line. Alright, here's x, and we're looking at f double prime, and then you put the tick marks at 3, right? Because it's not defined there. So before 3, we can try x equals 2, and after 3, we can try x equals 4. If you plug in 2, so you have a 2 minus 3 is negative, negative cube is negative, 20 over negative is negative. If you plug in 4, everything is positive. Right? So we know that the original function is concave down, then after that, concave up. Right? So let's look at that. So concave down on negative infinity to 3 and concave up. So this is it. Alright, so we got that. And inflection point, let's see, is there inflection point? Alright, it changes concavity at 3, but the 3 is unfortunately not included in the domain. There is no inflection point. Right? So we have that. Alright, then we want to find the correct picture. So always decreasing, concave down to concave up. So let's find the picture like that. This is increasing, so this is always decreasing, and a concave down and a concave up. So this looks promising. Alright. And this is decreasing, and actually looks like a vertical asymptote is at negative 3, but it should be at the positive 3. So this is more like it. This is not it. So check the answer. We got that. Alright, that's it. I hope that this was clear.